Hello and welcome learners. In this video, we are going to be discussing creating copies of the list and using them. Whenever we are working, sometimes we need to keep the original work intact. That is true in case of creating these objects. So, let's start by creating a list and creating a copy using an assignment operator. So I create a list, let's say called fruits and veggies. Okay. So here I create a list out here where I first mention certain fruits, let's say apples and grapes and bananas. Yeah. And then as another list, I mention some vegetables like potato, tomato and cabbage. Yeah. So I've created this list. Before any manipulation, I would like to save this list somewhere so that the original is not lost. So what do we do is, the basic idea is to create a copy of it using an assignment operator. Right now, both of these lists, let's call them original and copy, okay, contain same elements. Okay. So this is the copy of the list. Here we go. Both of them contain same elements. Let's do one thing. Let's try and insert or make change in one of these. So we pick up fruits and veg, the original one, and do a simple insert at the first position of, let's say, a fruit pineapple. What do you think is going to happen to the copy of it? Let's check. This insert has happened only on the original, that is the fruits and veg list. However, if we will check, that change is reflecting in both. This is because when we are creating a copy using the simple assignment operator, in that case, it just copies the reference. Okay, it just copies the reference of it. So there's a list which was created, and fruits and veg, the variable, was pointing towards that list. When I use the assignment operator, this new copy also started pointing to the same memory location. So in this manner, whether I make changes through the first variable name or the second variable name, the change is happening at the same memory address. That's why the change is reflected in both the cases. So this is obviously not what we are hoping for. So now what? Well, Python supports two concepts of copy. One is a shallow copy and the other is a deep copy. Let's have a look at them. To start with, shallow copy. Okay. A shallow copy of a list simply creates a new list object but referencing to the same objects as the original list. Okay. So we will go back to create these two lists, right? So I'll create this list first, once again, without any changes. So I'll copy the code here, creating this list. Here we go. Let this be our original list. Now, For creating shallow copy of the list, we need to either use the copy function associated with list, or there's a package called as copy which provides the shallow copy function. Okay, so either for the shallow copy of the list fruit and veg, okay, we will use copy function from this copy package and create a shallow copy of this list right here. Alternatively, you can also use the function like this. Here we go, fruits and veg dot copy. This also creates the shallow copy of the object. But how does it work? Let's again try and make changes to the original one. So we'll go fruits and veg and use an insert at 0th position and add the same pineapple over this. Let's have a look at the original and the copy. So the original is fruits and veg. Here we go. While the copy is, or rather the shallow copy is this. Here. Okay. Just to match this up, we'll use the shallow copy right here to check. Here we go. What do we observe? In this case, when I try to add the element, that is pineapple, to the original list, it does not get added over here. Okay? Pineapple is existing in the original list where I made the insertion change and does not occur in the shallow copy. But then why is it a shallow copy? Is that about it? No. There is something else. Let's try something else. To this, okay, we have inserted element at 0th position of the list. Let's try and insert something to the nested list over here. How? So we call fruits and veg. For the nested list, -1. This gives me the nested list. And now I can again use the insert function. And at 0th position, here I insert okra in all caps. Let's execute this and recheck our original and shallow copy. The expectation should be that it will not be added, but it is. So, what happens in shallow copy? Shallow copy only copies the outer structure of the list, but it maintains the references to all the nested objects. So this list over here in the shallow copy and this list in here in the original still have or share the same memory location in case of shallow copy. So if I make changes to the nested list, they will be present in both the cases. So what's the solution? Solution is the deep copy. If you want to create a completely new list and at the same time new copies of all the objects, not including the references, then you go for deep copy. Deep copy is available in the copy package only. So let's go back and create our very own fruits and vegetables again. Okay. And now we will create the deep copy of it. Okay. So let's call it deep copy, and for creating that under copy package, we have a function called as deep copy, and now we pass our data over here, fruits and veg. Now a deep copy is generated. Both of them right now contain the same element. Let's try the same changes that we did. We'll use the insert function. At 0th position, we'll try and insert pineapple and check the original versus the deep copy data. So this is the original here versus the deep copy. Here we go. Here. The change does not happen in deep copy. Pineapple only occurs in the original list where we brought about the insert, but not in the deep copy. Now let's check for the nested objects. So again, we'll go ahead and to the last element, that is the vegetable section of it, using -1, we access it and we insert at again 0th position of this the element okra. Let's again check the deep copy and the original version, and voila, we don't have that problem anymore. So deep copy creates a completely new object with new nested objects also. However, shallow copy does create a copy of the top level structure of the list, but not of the nested objects within it. So if we bring any changes to the nested objects, those changes will be reflected in any shallow copies of that also. This completes our discussion about list. Next, we'll talk about the other data structures of Python.